Okay, so let's talk about piecewise functions. The title actually says everything. Piecewise functions. I have a function that's in pieces. For example, if you take a look at what I've written up here, I see f of x written one time. This means I have a single function, and in this case it's broken up into two pieces. With me? One function, in this case, two pieces. We could have it broken up into three pieces or more, all right? But for this example, it's broken up into two pieces. Now, according to the first piece is 2x. Now, I'm only allowed to use that first piece, that 2x, if my x's are less than 0. It's the only time I can use the 2x piece. Got it? Okay. The next piece, x plus 1, I'm only allowed to use the second piece if the x's are greater than or equal to 0. With me? Does this make sense? Two pieces. Okay, so let me create a little table here for us. As with functions that we're not sure about, okay, we plug in numbers for x and see what comes out for y, right? Okay, and some people only plug in positive numbers. Well, you should plug in positive, negatives, and the neutral number of 0. So let's take a look here. I think I want to plug in -2, -1, 0, +1, and +2. With me? Okay, so if I want to plug in -2, x is equal to -2. Well, according to these two restrictions, since -2 is less than 0, then I must use the first piece. So to figure out f of x, I need to use the 2x piece because my x is less than 0. With me? Which means I'm going to do 2 times -2, which gives me -4. Got it? Okay. The second number is -1. Well, according to these restrictions, since -1 is less than 0, then I need to use the 2x piece again, which means I would do 2 times the -1, which would give me -2. Does that make sense? Okay. The next number is 0. Now, x is equal to 0. According to these two restrictions, which restriction actually has x equal to 0? Yes, this piece does. The second piece has x actually equaling 0, which means in this case I would use the x plus 1 part of the function, which means 0 plus 1, which is 1. Good? The third number is 1. And since 1 is greater than 0, I'm going to use the second piece again, aren't I? Which means it's the x1 piece. Does that make sense? Getting the hang of it? And then that last number of 2, correct, we'll plug it into the second piece again. So I would plug it into the x1 piece since 2 is greater than 0. So, with me? Okay. So now let's graph this. Let's see what this looks like, shall we? Okay. Now, the first number we plugged in was -2, and when we plugged in -2, we got -4, didn't we? So I have -2 and -4. The next number was -1. We plugged it in. We got -2. Got it? Okay. Now, these two I connect, and since 2x is linear, I know I'm getting a line. Agreed? So I know this line is going to connect down this direction. My challenge is where this line actually stops. Because since this is a function in pieces, this line is not just going to keep on going. It stops somewhere. And according to the restriction, it's going to stop at 0, isn't it? Now, I have a couple of choices here. I can plug in all the numbers between -1 and 0 and see where this goes, or I could literally plug in 0 to the 2x. Now, I know I can't plug it in, right? Because x was not equal to 0. But on this first piece, if x was actually equal to 0, then I would have, again, on the first piece, if x was allowed to be equal to 0, then I would do 2 times 0, which would give me 0, which means I'd have the point 0, 0, wouldn't I? Which means right here is where we would end, wouldn't it? But was I allowed to let x actually equal to 0? You're right, I wasn't. So remember with the inequalities, when you had an inequality and it was not equal to, what did you put? An open or a closed circle? An open circle. So I'm going to put an open circle here at 0, 0, because I wasn't allowed to let x equal 0 on this first part, but if I had, I would have gotten the point 0, which means this is where this piece of the puzzle, or this line, would have actually ended. It would have ended at 0, 0. Good? Okay. Now let's look at the second piece. The second piece, I was actually able to plug in 0, and I got 1. The next number of 1, when I plugged it in, I got 2. And this next number of 2, when I plugged it in, I got 3. So these I'm able to connect, and it goes out here. Now, it's normal for the two pieces to not connect to each other. So don't worry about that. You're like, they're not connecting. That's okay. Don't worry about that part. Got it? Okay. So this is what this piecewise function looks like when I graph it. Cool? All right. Now, I want to look at the domain and the range of this function. So let's look at the domain first. The domain refers to the input, which are our x's, right? So if I'm taking a look at my graph, and remember, x's go left to right because we go from the smallest to the largest. I'm going to start over here at the smallest x's, so I'm starting from the left. When I'm starting from the left, do you notice this graph keeps going, right? So this graph is using all these negative numbers, isn't it? Yes, this part of the graph is using all these negative numbers from negative infinity all the way to 0. But it doesn't use the 0, does it? But this part of the graph uses x equaling 0, so it didn't skip a beat. In terms of the x's I'm using, it didn't skip a beat. I'm starting at negative infinity, and according to this graph, I'm using all these negative numbers up until 0. And it's not using 0 on this part of the graph for x, but this part of the graph used x equals 0, which means it's still moving on without skipping a beat. And this graph keeps going, so it looks like it goes all the way to positive infinity. Let me show you another way you could have figured out what the domain was. We have our function, right? Do you notice the first part of the function says that I can use x's that are less than 0? So that's from negative infinity all the way to 0, isn't it? And the second piece actually lets me use x equals 0. And all the numbers greater than 0. So the restriction already told me, use all the x's less than 0 for the first piece. The second piece will actually use the 0 for x and all the way to infinity. So these restrictions verify the domain that the graph told me. Good? Okay, let's look at the range. Now the range is the output. And in this case, the output are the y's. Y's start from the bottom and go to the top, because I start from the smallest y's to the largest y's. Got it? All right, so this graph keeps going, doesn't it? So this range is starting at negative infinity, isn't it? And according to this graph, I'm getting all these negative numbers up until y equaling, up until the y equaling 0. But then do you see this gap right here between the 0 and the 1 for the y? Well, so be it. There's a gap. So this part of the graph, the y's stopped at 0, but it didn't use the 0 for the y's. The next part of the graph literally picked up at 1 with a solid dot, and this part of the graph goes all the way to infinity, doesn't it? So the range is in two pieces, from negative infinity up to y equaling 0, because the next part picked up at y equaling 1 all the way to infinity. And remember the inequalities that we graphed before? When I have two intervals, how do I combine them to one? Yeah, you use the union symbol, the or. My range is in this interval or this interval. Does this make sense? Are you with me? Okay, hang in there for... Okay, so let's look at the second example. Here's another piecewise function. They're asking us to graph it. So, what would you like to do first? Yeah, let's make a table. I agree. You know, for us visual people, it would be really good to make a table. So, let's actually take a look also at what the piecewise function is telling us. According to this function, the first piece of x plus 3 can only be used if x is less than negative 1. The second piece, negative 2x plus 4, can only be used if x is greater than or equal to negative 1. Got it? Okay, so let's look at this. You know, since my dividing number, so to speak, is negative 1, I'm also going to choose negative 3, negative 2, negative 1, 0, 1, and 2. Cool? All right. So I want to plug in x, negative 3 for the x. Which piece do I use, the first one or the second one? Good, you use the first one, because the first one says you're only allowed to use this piece if x is less than negative 1. Negative 3 is certainly less than negative 1, so I'm going to use the x plus 1 piece, which is going to give me negative 3 plus 1, negative 2. Good? The next one, negative 2, which piece, first or second? Good, first piece again, because this first piece is used only if x is less than negative 1. Well, negative 2 is certainly less than negative 1, so I'm using the x plus 1 piece. Got it? Okay, so I'm going to have negative 2 plus 1, which equals, good? Okay, negative 1. Now, negative 1 is my x value that switches from the first piece to the second piece, isn't it? Do you remember on the last problem, or the first problem that we did just a couple minutes ago? Do you notice when I started graphing, I actually needed to plug into the 0, pardon me, I actually needed to plug into the 0 to that first piece on the last problem so I could see where the first piece ended? Okay. I recommend that here also. All right? When we come to the x value that splits the two pieces up, I actually recommend plugging it in to both pieces, because it's going to tell me where one piece ends and the other piece starts. Now, if I plug in the negative 1 here to the first piece, is x actually allowed to be negative 1 on the first piece? No, it's not. So on this one, remember, just like the last problem, we're going to put an open circle on this one. This just tells me where this first piece is going to end when I look at the graph. So, plug in the negative 1, and I get 0. Remember, this one is going to be the open circle. I'm not going to be allowed to actually use that point for the first graph, but it shows me where it ends. So hang in there if you're like, I'm not quite sure what you're saying. Hang in there. It'll become more evident when we graph it. Okay? Now, negative 1, I'm actually allowed to use in the second piece, because the second piece says x actually equals negative 1. So I'm actually allowed to plug in that negative 1 into the second piece. So we'd have negative 2 times the negative 1 plus 4, wouldn't we? What'd you guys get? Good, 6. And then I can plug in the 0 to which piece, first or second? Good, second piece, because 0 is greater than negative 1. And when you plug it in, what do you get? Good for positive 1. Yeah, positive 1 goes into the second piece because positive 1 is greater than negative 1. With me? Making sense? Okay, and what'd you get? Good 2, and this last one. Yep, it goes into the second piece. I'm plugging 2 in. And so when you plug it in, what do you get? Yes, you get 0. Good. Excellent. With me? Okay, so let's graph it. Okay. Now, I know if you guys have graph paper at home, you should be using graph paper because it'll make this a lot nicer when you're graphing. And for those of you who don't grab graph paper, then you're going to have to do like I'm doing and try to make a nice, neat graph. Okay, so the first number we plugged in was negative 3. And when we plugged it in, we got negative 2. The second number we plugged in was negative 2. And when we plugged it in, we got negative 1. The next number we plugged in was negative 1, and we got 0. But remember, this is the open circle one because I was not allowed to plug in negative 1 to the first piece. But at least I know where the first piece ends. This is the point where it ends. If x was actually equal to it, I'd have a solid circle, but x can't be equal to it. So it's an open circle, but at least I know where this first piece ends. It ends at the point negative 1, 0. Does that make sense? Okay. Now, let's look at this negative 1 again. When I plugged it into the second piece, it was allowed to be equal to 6. This one's our closed circle. Because I could plug negative 1 into the second piece, and when I did, I got 6. Got it? Okay. Plugged in 0, we got 4. Plugged in 1, we got 2. Plugged in 2, we got 0. And again, we know that this is a line also, and yours probably looks better than mine. Good? Okay. Does this make sense right here? Right here, I had us plug in the negative 1 twice. Once to the first piece, even though I couldn't use it. But I really made it obvious that I needed to put an open circle when I plotted this point. And I plugged in negative 1 again, but now to the second piece where I actually was allowed to use it. Cool? So when you've got this x value, that's the actual x where the pieces will switch, like we went from the first piece to the second piece, it switched from first piece to second piece at negative 1. I recommend writing it twice here, because that way I could actually see where the first piece will end and the second piece will start. Cool? Okay, so I want to look at the domain. And you may already know the domain. Because remember what I said, if you look at the restriction here, that will also tell you the domain besides looking at the graph. Now if I look at the graph for the domain, those are my x's. And when I come in from the left, I'm noticing this graph keeps going. So my x's are going to start at negative infinity, aren't they? Now, every x value is used, and according to here, it stops at the negative 1, and I can't use negative 1 for x. But the second graph was able to use negative 1. And so, that's right, in this case, all the way to infinity. And according to the restriction here, all my x's below negative 1, so in other words, I can start all the way at negative infinity, go to negative 1, and piece number 2 allows me to use a negative 1 for x all the way to infinity. Cool? Okay, now let's look at the range. Now the range of the y's, right? Because that's my output. And I start in from the bottom. So when I do this, both graphs are heading down towards negative infinity, right? So both graphs keep going. So the first y value I get is negative infinity. And as I keep going up, let's look at this graph over here. I'm using all the y values, and this is where these y values stop at 0. But this graph over here picks up the y equaling 0, doesn't it? Because remember, this point was 2, 0. So this y value is picked up on this graph. So all the y's keep getting used right till this point. This is where my y's end. And what is that y value? And if you're not sure, look at the point. That was -1, 6, wasn't it? My y values in this case actually stop at 6. And yes, I put a bracket because that was a solid dot. With me? Okay, so again, in this case, your y's start at -infinity because both graphs keep going down. I'm getting every y value, and this one may end here, but this one has the y value of 0, and it keeps going up until that point where the graph finally ends. And it ended at 6 for the y's. This is one function. It's in two pieces, but it's one function. And the graphs, you're like, those are two different graphs. I get that's two different graphs, but in actuality, it's a single graph because it came from a single function. With me? Okay. So hang in there. I got one more example for us. Okay, so let's look at this last problem. It's a piecewise function. It's in two pieces. So, yeah, let's look and see what it says. The first piece, I get -1 if I'm using x's that are less than or equal to 0, correct? The second piece says I'm going to get -3 if x is greater than or equal to 2. This one looks interesting. So, let's create that table for ourselves, shall we? Okay, so we have our x's, we have our f of x, and I'm going to plug in the numbers I like to plug in normally. Oops. Okay, so I want to plug in -2. Well, -2 is less than or equal to 0, right? It's less than 0. So according to this, I'm just going to get -1, aren't I? So be it. X is equal to -1. That's still the first piece because that -1 is less than 0, right? Well, according to the first piece, yeah, all I get is -1. Agreed? Okay, I'm going to plug in 0, and I'm still using the first piece because the first piece says x actually equals 0, doesn't it? So, yep, I get -1. And now I want to plug in 1 for x. Well, now this one's interesting because according to this function, this piecewise function, the first piece is using all the x's up until 0 and x equaling 0. The second piece starts when x equals 2. I don't see a place for x equaling 1, which means I can't use the 1 for x. Does that make sense? So be it. Which means I'm going to start at 2. So when x is equal to 2, I'm using the second piece, and I get -3. And when I plug in 3 for x, I get -3. Got it? Okay. Well, let's see what this graph looks like. Again, if you've got graph paper, awesome. If you don't have graph paper, just try to draw this as neatly as you can. Okay? All right. So, I plugged in -2. I got what? -1. I plugged in -1. What'd I get? -1. I plugged in 0. I got -1. And that's where it ended, didn't it? What happens if we had plugged in -3? Yeah, I would have gotten -1. So this looks like, the first piece looks like a horizontal line, right? At y equaling -1, isn't it? Well, so be it. The second piece started when x was 2. And when I plugged in 2, I got -3. And when I plugged in 3, I got -3. What happens if you had plugged in 4? Yeah, you would have gotten -3. So it looks like the second piece started x equals 2, and it looks like the second piece is also a horizontal line, and that horizontal line is known as y equals -3, isn't it? Okay. So, in this case, my piecewise function is split up into two horizontal lines. Got it? All right, let's look at the domain for this. All right, so my domain is my x's, right? Because that was the input. Starts at negative infinity, good. And it goes all the way up until, yeah, x equaling 0. Because then there's a gap right here, isn't there? There's a gap from 0 to 2. This isn't used at all, isn't it? This is totally out of the picture here, isn't it? I'm going to draw it up there. Right? The x stopped here at 0, and then it didn't pick up again until 2, so all these x values between 0 and 2 aren't even being used, are they? So my domain picks up again at 2 and goes all the way to infinity, doesn't it? Yep, got to put the union in there to keep it as one sentence, one answer. Okay? Okay. Now the range. Well, in this case, the range is made up of two numbers. One number is -3, right? And the other number is -1. That's it. It's made up of those two numbers only, and that's it. Got it? Okay, this one was an interesting one. It's the same as the other ones. You just got to be careful, because in this case, these two functions that it was split up into were actually just constants, which told me I was going to get horizontal lines. Now, mind you, sometimes the piecewise function is split into 3 pieces, which means you have one more step of work. Cool? Okay, so you have fun with piecewise functions, and I'll catch you on the flip side.